Hey, algebra students, welcome to our MathABILITY practice for lesson 4 of Algebra Essentials, Intro to the Formula Sheet. MathABILITY is for those students who struggle a little bit with the algebraic symbols, like you work with algebra and it still seems to keep not making sense. That's who I'm thinking about, although everybody else is welcome too. It provides the opportunity, like my old tutoring students used to have a little bit of guided practice before you start trying to do your independent practice. One of our main goals here is to give you a verbal script, some prompts that you can use. So we're going to start with me prompting you a lot until you kind of already know these questions, you know these phrases, so that when you get stuck or lost when you're practicing or you're testing, you're able to get yourself unstuck. So turn to 1.4 MathABILITY in your workbook and let's get started. Directions say for each of the following, the formula has already been given. Find the indicated information by substituting known values into the equation, then simplifying. All right, so there was a few skills highlighted in this lesson: choosing the correct formula, substituting into the correct formula, and simplifying. So we're going to skip the choice for now and just practice the substitution and the simplifying with some of the work done for you. So number 1 says find the area of a square with a side length of 6 inches. And I've already given you the formula. Let's practice reading it together. It says A equals S squared, or S to the second power. Now, what does that mean? One way to think about this is to find A. Well, look at our problem. What do you think A stands for? A is the area of our square. So to find the area, it's going to be equal to S raised to the second power. Well, what do you think S stands for? We'll take a look again at our problem. It says find the area of a square. Okay, a square starts with S, but it's not a measurement. With a side length of 6 inches. So yes, S stands for side length. So I'm going to take note of that here. If A stands for area and S stands for side length, yes, we can read this as A equals S squared, but we can also think of this as to find the area, raise the side length to the second power. Now let's think about what we did in last class. We were practicing substituting into expressions. And no, technically this formula is not an expression. It is an equation, but all an equation is an expression equal to an expression. So I have a very simple expression, A, or area, equivalent to or equal to another expression, S squared. And so I can still do substitution. I can still plug in any known value. And if I end up with an expression I know how to simplify, I can do that. Let me show you what I mean. So let's go looking through our problem for what we know. We do have a number here. Notice it says find the area. So this is the mystery of a square with a side length of 6 inches. The area is a mystery, but the side length is not. I'm going to say that again. The area is a mystery. We don't know what A is, but the side length is not. We know what S is. S is 6. Now you're going to notice that I put parentheses there for you, and that's because, as we learned last class, that whenever you have a square or an exponent, it is a good habit to plug your number in with parentheses. And now all you have to do, you guys, is simplify. And so I'll do that in my calculator. Open up the parentheses, 6, close the parentheses, and square. Enter, I get 36. And again, I didn't want you to focus on units. I didn't want you to focus on too much on meaning right now. We'll go deep dive into that if you join us for the geometry unit. But for right now, we're going to focus in on the fact that the area is 36. Now, 36 what? Square inches. And what we mean by that is if we have 6 inches going this way and 6 inches going this way, we can extend those ruler lines and we'll end up with 36 little boxes. And that's why we call them square inches. They're little squares. But again, just let that kind of wash over you. So there is our final answer. A is equal to 36 inches squared, or square inches. And we can, again, read it that way, or we can think of it like that. The area is, of course, that's 36. And this is not math to do. That's the abbreviation because mathematicians don't like to spell the word square for square inches. Represents one of those little boxes. That's 1 inch this way and 1 inch that way. All righty. Now we have a few more like this. Why don't you go ahead, pause me, pause the video, try 2 and 3 on your own. Then if you need help, you get stuck, or you're ready to check your answers, turn me back on and let's take a look. So number 2, find the perimeter of a square with a side length of 8 inches. And again, they gave us the formula P is equal to 4S, or the perimeter is equal to 4 times the side length. Now notice what happens on the second line. Perimeter is the unknown. It's what we're finding. It's what we don't know. And so we see that on the second line, P is still P. We haven't traded it out. We haven't substituted anything for P because we don't know what P is. Our 4 remains a 4. But why did I open up parentheses here? See how the 4 and the S were shoved together? The 4 and the S are multiplying. And so this time I've opened up parentheses to signal it's going to be 4 times something. 4 times what? The side length. And you guys, we know what the side length is, right? Our problem tells us. Go back up and look. We have a known value. We have a side length of 8 inches. So we will trade out the S for an 8. And now that's just calculator work. 4 times 8 is 32. Now this time perimeter is measured in straight inches, not square inches. Again, just let it wash over you. But that's because when we look at the perimeter, we're going around the outside. So many inches plus so many inches plus so many inches plus so many inches. Not measuring squares, measuring lines. Let's look at number 3. Find the area of a rectangle with a width of 5 inches and a length of 7 inches. So they give us, again, the formula. And yes, one way to read this is A is equal to LW. But what does it mean? It means that the area is equal to, or you can find area by taking the length and the width and doing what with them? See how they're shoved together? When letters are shoved together in algebra, they're multiplying. So to find the area, multiply together the length and the width. All right, let's follow the directions that we wrote about. Notice my A is still an A. Why? Because I've been told to find the area. The area is the unknown. When we don't know something in algebra, we use a letter. So I'm still saying the area is equal to. But I've given you parentheses for the length and the width here. And notice how those parentheses are shoving together. Just like the L and the W were multiplying, I want their numeric values to multiply. So let's go find those numeric values. So first we have L. So in my problem, let me see, find the area of a rectangle with a width of 5 inches and a, there we go, length of 7 inches. Next thing I wanted was the W. Where is that? Find the area of a rectangle with it. There we go. Width of 5 inches. Our W is 5. And now this is just calculator work. 7 times 5, enter, 35. And again, these 3 lines, the formula, the substitution, and what we think of as the solution. I call it a solution now because it actually does say A is equal to blank. Like when we were solving equations, our final answer said A is equal to blank. And it is a simplified solution. We simplified to find it, 7 times 5, but it is a solution. We know what the unknown variable is equivalent to. Lovely. Just want to do a 4 together so you guys don't freak out about the fraction. So again, find the area of a triangle. This is my unknown. I don't know what A is. With a base of 8 feet, my B is equal to 8, and a height of 5 feet. My H is equal to 5. All right, let's go ahead and plug into the area of a triangle formula. So once again, they gave you the formula. That's that first line. A is equal to 1/2 BH. Let's think about what that means. It says the area is, or to find the area. And then we see 1/2 B and H shoved together. So those 3 things are multiplying. It's 1/2 times B times H. And we learned back in the basic operations that another way to think of multiplying with fractions is to say of. It's a scalar. We're scaling it to half of its size. So you could also say A is equal to 1/2 of B times H. All right, we see again, A is the thing we're finding, so it remains a letter. And of course, that's still equal to 1/2 times B and H, but we know the numbers for B and H. We had said B was 8 and H was 5. And now we can plug this entire expression. It might be ugly, but it's all numbers into our calculator. And to do that, remember, pull out an N over D button to get 1/2. Now, here's a super important part. If you keep trying to type your 8 times 5, look what's going to happen. You're in the fraction. You do not want to be in the fraction. You want the 8 and the 5 to be multiplying the entire fraction, not inside the denominator. And so when you have your 1/2, make sure you arrow right to get out of the fraction before you multiply by 8 and 5. So we have 20 square feet for number 4. And again, it's area, so it's measured in squares. Area means covering something in squares, which is why I have the little 2 here, but no big deal. If that doesn't make a lot of sense to you, the goal right now is to focus on how to get the number portion. Okay, I tried number 4. Number 5 is the same basic idea. Why don't you go ahead, pause the video, try number 5, and then join me if you get stuck or when you're ready to check your work. So 5 says, find the area of a triangle with a base of 12 centimeters and a height of 13 centimeters. And I will draw you a picture this time. So if we're looking at a triangle, the base is a side, but it's a special side. It's the side that goes perpendicular to what we call the height. Now I say perpendicular, it's basically like a right angle, a 90-degree angle, like the angles in your house between the wall and the floor. You want your wall to be straight up from the floor. You don't want it to be leaning, whether it's leaning out or leaning in. That would be not a good situation. All right. So same idea there. So according to this problem, we're finding the area, and we see that our A is remaining A, and we know the base is 12. And we know the height is 13. So let's plug in our known values. So instead of seeing B, we'll now see 12. And see how it's in parentheses? It's shoved up against 1/2, so it's multiplying. And we know our H is 13. And now we can type the entire thing into our calculator. 1/2, arrow out of the fraction, times 12, times 13. And I get 78 square centimeters. Sweet. Okay, number 6 says, find the distance traveled if a car travels for 3 hours at a rate of 65 miles per hour. Now, geometry, those shape formulas are not the only ones on the formula sheet. If you go down to the bottom, you will find the distance formula. So distance formula, sometimes I call it the dirt formula. Nobody else does that I know of, but I do. But the D, of course, stands for distance, to find distance. The R stands for rate. Rate is the same as speed, how fast something is moving, like miles per hour or meters per second. A big clue that I'm talking about a rate or a speed is the word per or the symbol per. So it could be miles per hour or meters per second, but a rate is how fast you're moving. And then T is just time. So if I'm in miles per hour, T would be the hours. If I'm in meters per second, T would be the seconds. All right, now that we understand the formula, let's plug into it. So it says find the distance. So D is the thing I don't know. If a car travels for 3 hours, so that's hours, that's a measure of time, at a rate of 65 miles per hour, that's the speed or the rate. So R is equal to 65. Awesome, let's plug in now for the formula. So D remains D, because it's unknown. Of course, my equal sign stays steady. It does not move, but I know what my R is. I'm going to replace it with 65. And if R and T were shoved together, so they're multiplying. And so I have these two numbers in parentheses. I'm going to do 65 times something. Times what? Well, I know what the time is too. The time is 3 hours. And again, now's when we grab our calculator. So we'll do 65 times 3. And see that you could go 195 miles in 3 hours. All right, number 7 is similar to number 6. Pause the video, try it yourself, come back when you're ready. Number 7 says, find the total cost of purchasing 3.5 pounds of roast beef at $10.50 per pound. Now, it's not actually written out as a formula on the formula sheet. I think it actually says like cost is equal to, and they use some words. So this one's even easier, but I was too lazy because I'm a mathematician. So I wrote C is equal to NP. But anyway, what I'm trying to say is C is equal to the number of items you buy times the price per item. It's basically the same formula as the distance formula above, right? We have a rate, that's the cost per item, and we have a certain number of items. But let's plug into this. So find the total cost. C is what we don't know. C will remain C. We're purchasing 3.5 pounds of the roast beef. That's the number of items we're getting, 3.5. And there's the price per pound, the rate, or the price per pound. That's the P. So our P is equal to 10.5. Or 10.50 means the same thing. Okay, you guys. So now let's plug into the formula. C stays C because we don't know it. Equal sign stays steady. But I know what N is. N is 3.5, our number of items. And I know what P is. P is 10.5, our price per pound. And we can see again that the two are shoved together to tell us they're multiplying. And we'll do that work in our calculator. And we get 36.75. And of course, it's a cost. So you'll see that the unit I put there is the dollar sign. This is $36.75. Now, technically, that says 36 and 75 hundredths of a dollar, but we never say hundredths of a dollar, do we? Because we know what happens when you take a dollar, you break it into 100 pieces, it's a cent. So we would say $36.75. All right, let's look at number 8. Find the perimeter of a rectangle with a length of 7 meters and a width of 6 meters. Now, I just wanted to do this one with you because the formula got a little more complicated. There's more to do here, but it's the same basic process. Don't freak out. So here's the perimeter of a rectangle formula. They found it for you already. And you're going to see that we have that P for perimeter, and we have the two letters, L for length, W for width. And again, you don't really need to memorize these letters because the problem will give you information, but you should have a general idea when you see them. Oh, yeah, that makes sense. Length. Oh, of course, that's width. But we have some known values in the problem, right? We don't know the perimeter. That's a mystery. But we do know the length is 7 and the width is 6. Let's put in what we know. Perimeter stays perimeter because I don't know it. Equal sign stays steady. You never change numbers. There was a 2 here. There's a 2 there. But we see above 2 and L were shoved together. So 2 is multiplying with the length. And our word problem says the length of this particular rectangle is 7, so I'll plug in a 7. Now notice operations don't change. There was a plus, there's still a plus. And like we said, numbers don't change. There was a 2 and there's still a 2. But if I have a letter and I know what it's equal to, I will trade that out. So W I'm trading out for 6. And again, we have parentheses there to signal that those two things are multiplying. Now, this might look gross to you, but it's all numbers your calculator can handle. So 2 times 7 plus 2 times 6 gives us 26. So what's the perimeter of our rectangle? 26 meters. Okay, we practiced the substituting and the simplifying in formulas, the last 2 steps, but let's back up now and practice finding the right formula on the formula sheet. All right, directions say refer to the GED formula sheet to determine which formula would be most appropriate to find the indicated information. And this is the GED formula sheet that you will have available to you while you test. There's a little button on the screen you can click and this will pop up. And I highly suggest you use it. So number 9 says the area of a parallelogram, and we can see that it's the first section of the formula sheet that features the area. If I focus in on those area formulas, there's the parallelogram, there's the formula I need. A is equal to BH. So let's see, and it's C. Ha, cute. So the area of a parallelogram is C. Next one, perimeter of a rectangle. We said that perimeter section is right under area. Let's hone in on that. Now, what were we looking for? We were looking for the perimeter of a rectangle. So there's my formula. P is equal to 2L plus 2W. Looking through my selections here, that appears to be F. So number 10 is F, and I will cross that sucker out. Now, a note, take a look at the next one. It says the circumference of a circle. You can go looking through the headings on your formula sheet. You won't find circumference anywhere. And that's because it actually fits in one of the categories. You can see right here under perimeter, circumference of a circle is one of the perimeter formulas, because like perimeter, circumference of a circle measures the line around the outside of a circle. Of course, you'd need a piece of string instead of a ruler to do that. But yeah, we're coming around the outside with circumference. Now, this one is also tricky because there's two different formulas, okay? It looks complex, but it's not actually complex. It's because they give us three pieces of information in this line. So we have the formula C is equal to 2 pi r, and then it says or C is equal to pi d. Now, after C is equal to pi d, we see a semicolon. What comes after that is not the formula, it's a piece of information. They're telling you that you're allowed to use that decimal approximation, that rounded version of pi, 3.14. Every time you see that little pi symbol, you can just trade it out for 3.14. So let's see. Do I have any of those formulas here? Yep, I have the first one. C is equal to 2 pi r right here. So 11 is A. All right, pause the video, go try the rest yourself. Don't forget that if it's not about a shape, you need to get to the bottom half of the formula sheet. All right, let's start moving a little faster. Surface area of a sphere. So the surface area section is under perimeter. We can see sphere. Now careful, we see two formulas, an SA formula and a V formula. We're looking for surface area. So we don't want V, we want SA. It says the surface area is 4 pi r squared. There it is. I says, let's put I there. And yes, that little symbol that we said is about equal to 3.14. That's called pi. Cross that one off. Next one, simple interest earned on a loan. Guys, is simple interest a shape? Heck no, it's not. Let's get to the bottom of the formula sheet and look under that algebra section. And we can see simple interest is towards the bottom. And there's the formula, I equals PRT. And this one's nice. You don't have to memorize what the letters stand for because they tell you. Interest, principal, rate, and time. And that's a word a lot of students don't know. Principal meaning the original amount invested. So 13 is I is equal to PRT. There it is. That's G. Awesome. Total distance traveled is also down here, known as the distance formula. We said that was Mr. Dirt. So that's D. Volume of a cylinder. Oh, we're back to a shape. Let's go back up. Volume, like surface area, is a measurement on a 3D shape. So we're going to find it in that third section. And we were looking for volume of a cylinder. So I come down here to cylinder. And again, I have two choices, but I want volume this time. Choose the one with a V. So V is equal to, again, pi r squared h. V is equal to pi times the radius squared times the height. So that's L. Perimeter of a triangle. So now we're back in the perimeter section. There's the triangle. P is equal to S1 plus S2 plus S3. Don't freak out thinking that that's something I haven't taught you, those little subscripts on the bottom. This just means first side, second side, third side. So basically it says to find the perimeter, add up the three sides. 16 is B. 17, area of a square. So area is our first section. And if I want a square, I get A is equal to S squared, or S to the second power. And you see how that little exponent 2 got his name. He got his name from the area of a square formula. A is equal to S squared, E. 18, total cost of a purchase. Again, I'm not in shapes anymore. I'll come down to algebra. Total cost is the very last formula. And yes, technically it does say total cost is equal to number of units times price per unit. But you know I was so lazy that I just said cost is equal to number of units times price per unit. So I'm going to go ahead and call that H. And you don't need to memorize it this way. Okay, guys, you can use this when you go to take your test. But again, I'm just trying to reinforce that lazy language of algebra. Next one, 19, volume of a sphere. Again, volume is one of those measurements on 3D shapes. So I come down to that third section. And here we have a sphere. And we have two formulas, SA and V. And of course, if I want volume, I need the V formula. So V is equal to 4/3 pi r cubed. Volume of a sphere is K. And then we have surface area of a cylinder, still in those measurements on those 3D solids. Here's a cylinder. Surface area is that first formula. So surface area is equal to 2 times pi times the height plus 2 times pi times the radius squared, J. Nice. All right, you guys, let's put it all together. Directions say find the indicated information. So if they tell you to find perimeter, find perimeter. If they tell you to find area, find area. That's what I mean. By A, choosing the appropriate formula from the GED formula sheet. That's the first step you'll have to do when you test. Now, B, define your variables. You won't have to do this on the GED, but I want to do this again so we can make meaning of the letters. Then C, we're going to substitute our known values. That'll be your next step on the GED. And D, your solution. So here's the work you have to show me. But here's the exercise we're going to do to help our understanding. So directions say find the perimeter. I'm looking for perimeter of a rectangle with a width of 15 centimeters and a length of 21 centimeters. Let's go first find the formula. So we said perimeter was the second section down, and we're finding the perimeter of what shape? Of a rectangle. So there's the formula we need. P is equal to 2L plus 2W. Copy that down for that first line, the formula line. Now, again, let's think about what that means. P is equal to 2L plus 2W. We're saying to find the perimeter. The perimeter is equal to, so you can find it this way, 2 times the length. They're shoved together, plus 2 times the width. P stands for our perimeter. L stands for our length. And we know from this problem what our length is. Our problem said our length was 21 centimeters, so L is equal to 21. And W stands for width. And again, we know what our W is. The problem said the width is 15 centimeters, so W is equal to 15. All right, let's do our substitution now that we know what we know. So first of all, we don't know the perimeter, so it'll stay P, and that's going to be equal to 2 times the length. The length is 21. Now, don't forget to put your parentheses around them. I've been doing that for you, but I want parentheses around the 21. And that's going to add, this formula says plus, with 2 times the W. What is our W? Our W is 15. The entire right-hand side of the equation here is an expression. Again, the left and right-hand side are an expression. But the main thing I want you to see is it's an expression with only numbers. So I can plug the entire thing into my calculator. So 2 times 21 plus 2 times 15. And I get the perimeter is equal to 72. And 72 what? Well, perimeter, like we said, is just a line outside, so it'll be plain old centimeters. But that being said, the main part you need to understand is that the perimeter is 72. All right, you guys, I tried 21 for you. I want you to pause me and go try 22. And then you know what? Join me for 23 because it's a little tricky. 22 says find the area of a triangle with a height of 3.4 millimeters and a base of 4.2 millimeters. Okay, we need our area of the triangle formula to go start out. So we go grab our formula sheet. We're looking for the area of the triangle. We come to the area section, find the triangle, and we see that's A is equal to 1/2 B times H. Now let's think about what this sucker means. We said A, of course, we're finding the area of the triangle. A stands for area. B stands for, well, we got some hints in the problem, right? We have a height of 3.4 millimeters and a base of 4.2 millimeters. B stands for base. So our base is told to us in the problem, right? They say the base is 4.2. So our B is equal to 4.2. And H stands for what? Well, again, big hint in the problem. Height is 3.4 millimeters. H stands for height. So our H is 3.4. Plug into our formula. A is equal to 1/2. B is shoved up. It's multiplying. And I know what it is. We said B was 4.2. H is also shoved up. It's multiplying, and I know what it is, 3.4. The entire right-hand side is all numbers, so now I plug that entire expression into my calculator. And over D button for the fraction, 1 arrow down for the denominator, the 2 arrow out before you type the rest of that expression. And I get 7.14. So let's speak in a complete math sentence with our solution. The area is 7.14, and not a big deal right now, but yes, that's square millimeters, because area is how many squares to cover something. 23 I wanted to do together because the formula is a little funky looking, but we can do this, okay? So it says a trapezoid has a height of 8 inches and bases of 14 and 10 inches. Find the area of the trapezoid. It is the area we're looking for. The shape is the trapezoid. So I come to the area section, find the trapezoid, and there's the formula. And you can see it's a little ugly, and there's why I wanted to do it together. So let's write it down. It says A is equal to 1/2 times H times the quantity of, or the sum of, B1 and B2. Now let's think about these letters, what they stand for. Bet you know what A stands for by now, right? It was an area of a trapezoid formula. A stands for area. The tricky part here, I think, is B1 and B2. Students think it's math to do. It's not. Those little numbers on the bottom, those little like dropping numbers, those are called subscript, and they just mean first, second. If you have more than one of the same letter that stand for different things, we need to distinguish them. So they're first base and second base. A trapezoid is this shape that has these two parallel sides, these sides that run in the same direction. I can measure the height of the trapezoid, and then the base are those two parallel sides that again are at right angles to that height. So B stands for first base, or you could put base 1. And we can see we have these bases of 14 and 10 inches, and valid question, which one's first base? And great answer, it doesn't matter, right? We're just going to add them together, and it doesn't matter what order you add in. I will just use the first one, makes the most sense to me, 14. And B2, of course, stands for second base, or base 2. So B2 is equal to 10. And then what does the H stand for? The H stands for that height of the trapezoid. So the height is 8. Now let's plug into this very carefully. In fact, I'm going to bust out my different color like I like to do, because students really can struggle with these longer formulas. So first thing I should see is A, because I don't know what A is. Next thing I should see, my equal sign will stay steady. Numbers will stay steady. But what will change? Letters will change. And I know what the height is, so I can trade it out. We said the height was 8. I'll put an 8 here. Now, this is weird. I have 1/2 shoved against H. What are they doing? Well, we know when things are shoved together, they're multiplying. I need some indication of that now that I have numbers. Now, we see another parentheses opening here in our formula. So we need that same nice long parentheses in our substitution step. But B1 is going to change because I know what it is. We said our first base was 14, but there's also a plus inside those parentheses. Don't lose it. And now I'll replace B2. And notice I haven't closed my parentheses yet because they told me up above that base 1 and base 2 needed to be inside the parentheses. So base 1 plus base 2, 10. And now, once again, as ugly as this entire right-hand side expression might be, it only has numbers. And so I can plug it into my calculator. And over D button to do 1/2, arrow out of the fraction, enclose the 8 in parentheses because it's multiplying. Open up the parentheses to put that entire sum, that entire quantity of 14 plus 10. Enter, and I get 96. So I'm going to speak in a complete math sentence. The area is equal to, and again, it's from above, A is equal to, the answer I just got, this entire expression simplified to 96. And 96 what? It is area, so whatever unit I had is going to be measured in square units, because area is number of squares to cover. Like, how many squares would it take to cover up this whole shape? Strong work, you guys. You did a great job. Now you're going to go and you're going to practice by yourself, right? That's the next step, is independent practice. I helped to bridge you over there. And now you should have a script to prompt yourself. You should be able to say, okay, what am I looking for? What do I know? What formula should I use? What do the variables in this formula stand for? And then which ones are known? What can I trade out? And then finally, what can I use my calculator to simplify in order to find my solution? Lovely. Proud of you. Go get it. Go defeat the algebra. You got this. Happy learning.